My name is Skylar Vollmer. This is for SDI FTT 122, Introduction to Ammunition and Basic Ballistics. This is week 6 assignment. In this assignment, we are going to demonstrate and explain the following terms: trajectory and sights, gyroscopic drift, drag, Magnus effect, the Coriolis and Eötvös effect, vertical angles, and transonic ballistics performance. For the first section, trajectory and sights, I'm going to be using this flexible cleaning tool. So sights is, from what I understand on this, it's line of sight. Looking down your sights straight out is what you see, straight line. Now your bullet doesn't fly like that. Your bullet flies on a trajectory, which means it's going to actually arc. Rifle bullets arc like this, and I believe pistol bullets are more of a down and up. But I know rifle rounds fly like this, so it starts here, leaves your bullet straight, arcs up, and then comes down and meets the target. So that's sights and trajectory. Trajectory is the actual flight path of the bullet at an arc, and then line of sight is what you see on a straight flat surface or straight flat plane. The second term we're going to go over is gyroscopic drift, which is also known as spin drift, which most people know that as. And it's a very simple concept. As your bullet spins through the air, all rifling is right-handed. Every bullet spins right. So as this spins right, it pulls to the right. And so that's what it is. So as it spins, the force that's exerted on it will actually pull it to the right. So if you were able to shoot line of sight without trajectories and straight on, your bullet will hit to the right every time. The third term we're going to cover is drag. Now, drag on a bullet is just like drag on anything else. It's the friction of the air at the point of the object. So as this goes through the air, the friction of the air passing over the top and the bottom and the sides are going to cause friction and drag and actually slow your round down. The fourth term we're going to cover is the Magnus effect. If my understanding of this is correct, this is what gives the bullet trajectory. Now, when I say that is, as it passes through the air, similar to almost like an airplane wing, as it spins and flies through the air, it's going to create a negative pressure and a positive pressure, a low pressure and a high pressure side. And as that happens, it's going to move to the low pressure, so it's going to go up. If my understanding is correct, this is what gives the bullet the up. That's why you need trajectory. Once the Magnus effect is no longer in effect and gravity takes over, it pulls it down and meets the target. The next term is vertical angles, and what that has to do with is shooting basically uphill or downhill. And it's going to seem like you're going to miss your shots, but what the problem really is the judge of distance, because it can appear that they're closer than they are, and so you're going to actually overshoot. You're either going to shoot above them when shooting up, you're going to shoot up over them, or you're going to shoot above them when you're shooting down at them, just because it's an incorrect judge of distance. The next two we're going to do are the Coriolis effect and the Eötvös effect. Now, bear with me. I hope I got these right. So the Coriolis effect has to do with shooting in the hemispheres of the planet. In the north hemisphere, whether you're shooting north to south, south to north, the bullet is going to favor the right. If you're in the southern hemisphere, it's going to favor the left. It's going to go to the left. So you have to make calculations on which part of the world you're shooting in for which way the bullet's going to go. Now, the Eötvös effect has to do with east and west and the spin of the planet. Because if you're shooting far enough, where you're shooting isn't going to be in the same place as when you took the shot, because the Earth rotates. So as it rotates, so let's say, so the planet spins clockwise on a right-hand twist. If you're shooting from, this is just a broad term, let's say America to Africa. No, America to Europe, Northern Hemisphere. We'll stay in the Northern Hemisphere. By the time the round reaches where the target you're going to want to hit, that target has moved a significant amount due to the rotation of the world underneath the bullet. And so you have to take that into effect. Now, it's going to get there faster if you're shooting against the rotation. If you're shooting with the rotation, it's going to be farther away. The last term we're going to cover is transonic ballistic performance. Now, my understanding to what that is when a bullet slows down to subsonic levels at about 1,340 feet per second, what you're going to do is it's actually going to fall behind the sound wave, the shock wave of it, and it's going to create turbulence, and it's going to affect the ballistics of that bullet. The way to counteract that is a faster spin on the bullet. That concludes week 6 assignment. Thank you.